The British winter is famously unpredictable. One day might greet you with crisp, clear skies and a delicate layer of frost sparkling across the countryside, while the very next could bring heavy snowfall, relentless rain, or even a sudden hailstorm. The weather can shift in a matter of hours, keeping everyone guessing. This constant variability isn't just a topic for small talk. It shapes our daily routines, impacts the economy, and even influences our safety. From deciding what to wear to whether schools and businesses can open, the weather is always a factor. Predicting winter weather is one of meteorology's greatest challenges, with real consequences for transport, farming, and emergency services. A single miscalculation can mean chaos on the roads or delays for thousands of commuters. The UK's unique position, caught between cold polar air from the north and milder, wetter Atlantic systems from the west, creates a meteorological battleground. This clash of air masses makes forecasting especially tough as conditions can change rapidly and dramatically. Even a few centimeters of snow in London or a fierce storm in the Scottish Highlands can cause nationwide disruption, affecting everything from travel to food supplies. As our society grows more interconnected and reliant on timely information, the stakes for accurate, up-to-the-minute forecasts have never been higher. Technology has transformed forecasting from the days of barometers and weather lore to a world of digital models, radar, and powerful supercomputers crunching vast amounts of data. This evolution is a testament to human ingenuity and curiosity as we strive to anticipate nature's surprises and protect our communities from the worst of winter's wrath. In the next sections, we'll explore how forecasting has changed over the years, the cutting-edge technologies driving it forward, and what the future might hold for predicting the British winter. The quest to predict the British winter is a fascinating blend of science, technology, and careful observation, a story that continues to unfold with every passing season. Before the era of computers and advanced technology, weather forecasting was a painstakingly manual process. Meteorologists relied on their own eyes, careful observations, and handwritten notes to track the ever-changing skies. They used a handful of basic instruments: barometers to measure air pressure, thermometers for temperature, and anemometers to gauge wind speed, each one requiring careful calibration and constant attention. Every day, meteorologists would plot temperature, pressure, wind, and humidity by hand on large paper maps, connecting isobars and other lines to try to infer the movement of weather systems and predict what might come next. Forecasting in those days was as much an art as a science. Forecasters leaned heavily on their experience, intuition, and simple rules of thumb passed down through generations. The iconic shipping forecast, still beloved today, is a legacy of this era, offering mariners broad, generalized guidance about what weather to expect at sea, often delivered over crackling radio waves. But these traditional methods had significant limits. Forecasts rarely extended beyond 24 to 36 hours, and even a small change in the weather could lead to big surprises for those relying on the predictions. Without the benefit of satellites or computers, forecasters often missed the exact track or intensity of approaching storms, leaving communities vulnerable to sudden changes. Weather balloons, launched into the sky, provided only brief snapshots of atmospheric conditions, and vast areas like the Atlantic Ocean remained almost completely unmonitored, a true blind spot. Forecasting was like trying to solve a puzzle with many missing pieces, and as a result, surprise weather events, unexpected storms, sudden downpours, or snow were all too common. Despite these daunting challenges, forecasters managed to do remarkable work, piecing together what information they had and providing the best guidance possible with limited tools. Yet, the atmosphere often kept its secrets well hidden, leaving both forecasters and the public alike gazing skyward, still guessing what tomorrow might bring. The arrival of supercomputers has truly revolutionized the field of weather forecasting, transforming it into a highly precise science. Instead of relying on hand-drawn charts, meteorologists now utilize complex models that simulate the atmosphere in millions of data-filled grid boxes, capturing intricate details. These supercomputers perform trillions of calculations per second, enabling the creation of detailed forecasts that can predict weather patterns days in advance with remarkable accuracy. The UK's Met Office operates one of the world's most powerful weather supercomputers, capable of simulating complex interactions between air, ocean, land, and ice, providing comprehensive insights. Finer grids mean we can predict local events like snowbands or downpours with greater accuracy, offering communities better preparation time. Modern models now provide reliable forecasts up to a week or more ahead, crucial for navigating the unpredictable UK winters, where weather can change rapidly. The process starts with assimilating millions of global observations from weather stations, ships, aircraft, and satellites, ensuring a comprehensive data collection. This vast amount of data creates the most accurate starting point for simulations, forming the backbone of precise weather predictions. The result is a continuous cycle of observing, processing, and predicting, which enhances the reliability of forecasts. Supercomputers turn torrents of raw data into clear, actionable forecasts, which are essential for decision-making in various sectors. Every percentage point of accuracy can mean saved lives and protected property, underscoring the critical role of advanced weather prediction technology in safeguarding communities. Satellites are the eyes in the sky, providing the vital data that powers modern weather models. They fill gaps in our observational network, especially over the Atlantic, where most UK winter weather begins. Geostationary satellites offer constant images of cloud patterns and storm systems, while polar orbiting satellites scan the globe in detail. These satellites measure not just clouds, but temperature, humidity, wind, and even atmospheric gases. Instruments like microwave sounders and scatterometers help predict storm intensity and wind speeds. Satellites can even distinguish between rain, sleet, and snow by measuring cloud top temperatures. This data transforms empty oceans into data-rich environments, enabling timely warnings for severe weather. Without satellites, our ability to forecast winter storms would be severely limited. Artificial intelligence and machine learning are the newest tools in weather forecasting. Unlike traditional models, AI learns from decades of historical data, spotting patterns that physics-based models might miss. Machine learning corrects model biases, improving forecasts for temperature, wind, and rainfall. AI excels at nowcasting, predicting weather in the next few hours, by analyzing radar and satellite images for fast-moving events. Deep learning models can provide highly localized, accurate, short-term forecasts. Companies like DeepMind are developing AI systems that generate medium-range forecasts in a fraction of the time. While AI doesn't replace physics-based models, the future is a hybrid approach combining physical understanding with AI's pattern recognition. This synergy promises the most accurate forecasts yet. The fusion of supercomputers, satellites, and AI has dramatically improved UK winter forecasts. Predicting whether precipitation falls as rain or snow is now far more precise, thanks to high-resolution models. Windstorm forecasting has also advanced. Major storms are flagged days in advance, allowing timely warnings and preparations. Temperature forecasts are more accurate, helping energy suppliers and transport authorities plan ahead. Ensemble forecasting, running models multiple times with slightest variations, gives a range of outcomes and confidence levels. This means better risk assessment for ice, snow, and severe weather. Day-to-day forecasts are more reliable, letting people and businesses plan with confidence. Every accurate weather app notification is the result of decades of scientific progress. The impact is seen in saved lives, reduced disruption, and a more resilient society. Accurate winter forecasts benefit every corner of UK society. Transport networks can grid roads and prepare trains and airports, reducing accidents and delays. Farmers use forecasts to protect crops and livestock, making crucial decisions about planting and harvesting. City planners and emergency services rely on weather data to design infrastructure and coordinate responses to storms and floods. Energy suppliers predict demand spikes, keeping the grid stable, while retailers adjust supply chains for winter surges. Early warnings mean resources are used efficiently and lives are protected. The economic savings are immense, and daily life runs more smoothly. All of this is powered by the quiet work of supercomputers and meteorologists. Better forecasts ripple through society, touching everything from food on shelves to safe journeys home. Despite advances, forecasting UK winter weather remains a challenge. The atmosphere is chaotic, and even supercomputers can't eliminate all uncertainty, especially for local, high-impact events like narrow snowbands. Climate change adds complexity, bringing more extreme rainfall and shifting weather patterns. The UK's geography, small, surrounded by sea with varied terrain, makes local forecasts tricky. High-resolution models help, but subtle differences between valleys and hilltops remain hard to predict. Communicating uncertainty is another hurdle. Forecasts often use probabilities, which can be confusing to the public. Forecasters work to make warnings clear, focusing on impacts rather than just conditions. The goal is to ensure people understand risks and know how to act. Science must translate into meaningful action on the ground. The battle against uncertainty is ongoing, but every improvement makes a difference. The future of winter forecasting is even more accurate, detailed, and personal. Exascale supercomputers will run models at kilometer scale, simulating individual storms and showers. AI and physics-based models will merge, creating hybrid systems for faster, more reliable forecasts. New satellites and ground sensors will provide hyperlocal, real-time data, improving nowcasting and short-range predictions. Imagine cars reporting icy roads instantly, alerting drivers and gritters. Seamless prediction systems will cover everything from minutes to seasons ahead, helping sectors plan months in advance. As climate change accelerates, the ability to look further ahead becomes critical. The British winter will always surprise us, but our ability to anticipate it grows stronger every year.